Sir, if you are speaking, we can't hear you.
Am I audible now?
Yes, sir.
Yes, sir.
Okay. So let us begin with the new module. That is our 5th module. Okay. It is titled as Kinematics of Rigid Body. And your module 4 was Kinematics of the Particles. Okay. So let us see, even in this particular module, we are interested only in the motion, only in the motion of the body. Okay, motion of the body. Everyone, mute yourself. Okay. So we are interested in motions of the body and not interested in forces which are causing this motion. We are not bothered that how much force will be required. Okay, how much force will be required in order to cause the particular motion. Okay, so we are not focusing on the forces, we are just focusing on this motion. So in that, what comes is the displacement, uh, there comes the velocity, acceleration. Okay, and you study all these with respect to time, how these parameters change with respect to time. That is also important to understand any motion. Okay, so in this particular modules, we are going to cover different types of motions like translation, then how rotation is different from translation. Then there is another kind of motion which is known as general plane motion. Okay, and we are going to study this general plane motion of any rigid body, okay, using the concept of ICR. So you know that ICR stands for instantaneous center of rotation. Okay, then we will also be interested in locating the ICRs for different links. Okay, and again we will be doing velocity analysis of rigid body using ICR. So this particular method ICR we will use for just velocity analysis, not the acceleration analysis. We will not be doing that. Okay, so this particular method, which is known as ICR method, is especially useful for velocity analysis of the mechanism. I will tell you what is the mechanism, what are different parts of the mechanism, okay, and how we can study the velocity using this particular method, which is known as ICR method. So let's proceed further. Yes. So in general, by observing the motion of rigid bodies, you can classify the motion into three types. Okay, so one you can name as translation, one rotation, and one is the general plane motion. Okay, we will see these three types in details. Okay, so first of all, what is translation? Okay, so you see that again translation has two types. One is rectilinear translation and another one is curvilinear translation. Okay, so in this what happens, that a particular body, okay, say this is particular body A, it gets translated, to another position. Say it is position 1 and it is position 2. Okay, such that the orientation of the different particles on the body A remains same even in the new position. Okay, it will not happen that suppose this particular body is there, okay, and it has two particles A and B. So obviously one can see their orientation, that particle A is above the particle B. One can easily see it. Okay, so if the motion of the body is pure translation, that it is moving to a new position, then it will happen that at any instant, the position of A with respect to B will be fixed. A will always be above the point B, like this. So you can say that the body has just moved to the new position, maintaining its orientation. So you can say this particular body is translated to a new position. Okay. So see here, it is one body. Okay, this particular body. It has two particles, A and B. So what is done here? A line is drawn. Line is drawn connecting these 2 points. So we found that this line is vertical initially. It is coming as vertical initially. Now, when this particular body will move to a new position, so in new position also, the line between point A and point B, you will find that it is vertical only. Yeah, okay. This line is not tilted like this. ये line थोड़ा भी tilt नहीं हुआ है. Say A dash and B dash. Even during its path. Okay. So it is the first position, it is the final position, and there will be number of positions in between them. So in every position, you will find the line joining particles A1 and B1 remained vertical during its whole journey. So you can say that this kind of motion is translation. Okay. And as the path of all the particles are straight lines, so particle A has traveled in straight line, B has traveled in straight line. You can say that it is the rectilinear motion. Rectilinear motion. In this, the particles on the body travels in parallel straight paths. Parallel straight paths, you can say. Okay. Then there is another kind of translation which is known as curvilinear translation or curvilinear motion. So what happens in this? The path of the particles is a curve instead of a straight line. Okay. So body will move like this. Whole body will move like this. And but what will happen? The line which was vertical, okay, which was drawn between particle A1, B1, it will always remain vertical in any position during the journey as well as in the final position. If you find that at certain position, okay, this line became inclined, it changed its angle, then this motion will not be a translatory motion. Okay, it will be some another kind of motion. So you have seen that a translation will have two types, rectilinear one and curvilinear translation. Okay, so this is the first type of motion, translation. After that, which one is there? That is rotation. Okay, so see what happens in case of rotation. In case of rotation, when a body rotates, okay, at that time the vertical line or straight line drawn between particles A and B doesn't remain straight. Okay, it changes its orientation. One can see, suppose this is the body, this particular is the initial position of the body, and you are turning this body about point C. About point C में इसको क्या कर रहे हैं? We are turning it. Okay, so here the straight line which is drawn between these 2 points is changing its orientation. Sometimes it is becoming horizontal, sometimes inclined, like this. Okay, and particles present on the body, they travel in circular paths parallel circular paths. So that is called as pure rotation. Okay, so again there are two cases of rotation: when the body rotates about a point which is present or located on the body itself. For example, here we are rotating the body about the point C. Point C is on the body itself. So this is one case. Another case is when the center of rotation is not present on the body. See, it is located outside of the body. Here you can see, and around this point this whole body is turning, is rotating. So it is another case of rotation. Okay, so far we have seen the first type was translation. First type was translation. Second one is rotation. We have seen. Okay, and then there is third one, that is the general plane motion. Okay, so what is the general plane motion and how it is different from the first two cases? Okay, someone got unmuted. Okay, so general plane motion is the combination of translation plus rotation. If you observe the motion of the body, you will find that body is getting translated as well as rotated while it is moving from one position to another position. Okay, for example, you consider this rolling of a cylinder without slipping. Okay, so this is a cylinder. Okay, it has one more dimension, length, okay, which is not visible to you. This cylinder, or this you can say coin, is rolling on the surface. So when it is rolling about this point or any other point is there, okay, when it is rolling, then suppose I mark one point here, point B. What I will do, I will join the point A with point B, this line, and I will observe whether the line AB remains vertical or it changes in orientation. So what will happen when the this cylinder will roll? This line will definitely change its orientation. It will become inclined. Sometimes it will become horizontal. Okay, and as well as what is happening, that points are getting translated to a different position. For example, this center point A, after some time, this will be somewhere here. So there are both translation as well as rotation. Okay, so this kind of motion, which is a combination of translation and rotation, is called as the general plane motion. Okay, so you see here, so this is the original position. We have marked one point B on the periphery of the cylinder B1. Now you are rolling it. You are rolling this cylinder. So cylinder will move forward. Its center will come to this point, and the point B1, which is located on the periphery, okay, will come to this position. You will find that this line has changed the orientation. It is at some angle. So you can say that rotation is there, rotation is there. And again, the point A has changed its position from A1 to A2. So you will say that translation is also there. Okay. So it is called as general plane motion. You can consider this case, okay, as equivalent to this. For it is equal to just like the cylinder you just आपने उसको क्या किया, स्लिप किया, अभी वो रोल नहीं हुआ, आपने उसको जस्ट पुश किया इधर से, and the cylinder by slipping action it came to this position A1 to A2 and B1 to B2. So it is the translation motion. Okay, and after that what you did, you simply rotated the cylinder at this position about point A2 on its place. You did not allow it to move forward. So what will happen, this B1 point will come to B2 point when you will rotate this cylinder at point A2 and will not allow the cylinder to move forward. So you can consider this as an example of translation. पहले उसको यहाँ पे translate किया, and after that you just rotated it at that place. Okay, it is one example of general plane motion. We will see another example. Okay, yes, this is the example of ladder. Point A is here where the ladder makes contact on the vertical wall here. Okay, and point B is here where ladder makes contact with the ground. Now what happens, this ladder slips, ये ladder slip होता है. So because of that, its point A occupies a new point A2 and point B occupies new point B2. Okay, so what kind of motion it is? It is the initial position, it is the final position. So you tell me whether this motion, whether the ladder translated to the new position or whether it rotated to the new position. What is the motion of the ladder? Ladder has some displacement. Displacement is there, means motion happened. So which kind of motion happened? Translation or rotation? Any answer? Concentrate on this. You have been shown initial position as well as final position.
Translation.
Was it translation? Okay, then any other answer? So translation, you know what is translation? Suppose it is the orientation of ladder. Okay, say A1 and B1. So translation is how you can identify that its final position is parallel to it. अगर final position उसके parallel है A to B2, then you can say that ladder just translated to the new position. ऐसे translate हो गया. It is called as translation. But here you see initial position or final positions are not parallel. They are not parallel. You can't say that it is a pure translation. Okay. So if not translation, okay. So is it rotation then? Is it rotation then?
No.
So
Yes.
it will be then combination of both, no?
Yes, correct. So if you see in rotation, the particles move along the parallel circular path. But when you see here, the path of A1 and path of B1, they are not parallel, not circular. So it is neither pure translation nor pure rotation, but you can say that it is the combination of translation and rotation. Yes. Okay. And one can imagine, okay, one can imagine that, or if somebody wants to divide the motion into two components, then it can divide it like this. First, he will pull the ladder, okay, to next position. Means B1 point से उसको drag करना है ladder को to B2 position. So its next stage is this: A1, B2, A2, A1 dash B2. It drag किया. After that, after it dragging, क्या करना है? आपको B2 पे ये ladder को rotate कर देना है. B2 को ladder को about B2 rotate कर देना है. So this A1 dash point will rest on the vertical wall. It will come to A2 like this. So one can imagine it like this, that there is translation happened, also the rotation happened, and this is called as the general plane motion. Okay, so I hope that you understood the different types of motions: translation, rotation, and general plane motion. Now you can differentiate between them. Have you understood? Yes.
Yes, sir.
Okay, so you just write down the different types of different types of motions. Write down there are 3 different types. Okay, then we will see the new next topic. Take 2 minutes to note down.
Sir, do we have to note down this slide which you are showing right now?
If you feel like that I should take this point also, you can take it. Okay, you can take any point which seems important to you. Okay.
So what's the syllabus for IA2?
In IA2, you will have the curvilinear motion. Curvilinear motion we have seen in the last. Okay.
Yes,
Means
and
some part of module 4 and this 5th module.
so just the 5th module and curvilinear, no other modules.
Those other modules will be from the statics. Hemant sir will tell you that remaining portion.
Okay, sir.
Yes, this much portion from my side.
Sir, entire module 5.
Yes, it is very short. It is very short. अभी हो गया ये module हो
So
गया
by
आपका
when will we get the entire portion?
entire portion in final exams, university
No, no,
exam.
no. By when will we get to know the exact portion for IA2?
IA2 time is there na for IA2. IA2 कब से start हो रहा है?
So 1 week is only there.
Okay. So you understand this much? IA2 का इतना मेरा पोर्शन तो मैंने आपको बताया. You then contact Hemant sir, that he will say what he will include.
Okay, so thank you.
Is it done?
So also you'll be uploading practice problems on this topic on this module 5 on Moodle, right?
Practice problem means what?
Practice problems,
Means
questions.
for you to solve.
Yeah, just for practice, maybe solved examples as well.
Short examples also. Okay. So you can get the short example from books. Are you referring any?
No, sir, we were told that Moodle notes are sufficient mostly. So
Mm-hmm. Okay. Okay. Yes, I will then upload for you.
okay, thank you.
So is it done up to this? Should we move to the next point?
Yes, sir, you can.
Okay. So very important point now. Yes. All of you pay attention. So what is the concept of instantaneous center of rotation? Okay. As far as center of rotation is concerned, we already know it. Center of rotation, you know that it is the point about which certain body rotates, is called as center of rotation. Okay. So for example, you consider a disc. A disc is there like this. Okay. And you consider an axis. We assume that this disc is rotating. This disc is rotating about a point which is present or located on into the disc or in the disc. It is not lying outside. So in that case, what we call this point as, this particular point is known as center of rotation. Center of rotation. All of you are aware of this? Yes or no? Right? Understood?
Yes, sir.
Okay.
Yes, sir.
Similarly, we also know that center of rotation may also lie, okay, away from the body which is rotating. For example, suppose there is this curved path, okay, and on that curved path, what is happening, you know, that a vehicle is there, a vehicle is there which is moving along this curved path. Okay, so if I want to know, obviously this vehicle is rotating about certain point because it is moving on the curved path. Getting it? Okay, so where is the center of rotation of this car? जैसे vehicle जब turn लेता है कहीं पे, at the time of turning, it is moving along the curved path. Means you can say that this car is rotating about certain point. This whole car, whole object, where is the center of rotation of that car? कहाँ पे होगा? Yes,
Have to pull them out.
it will be at the center of this arc. Yes, correct. ये जो arc, जो curved path है, where is the center of that curved path? Okay, so say it is here. So this point will be the center of rotation. We already know it. Okay, now suppose after some time, as this curved path is over here, again the path becomes straight. After this, ये turn लेने के बाद क्या होता है? The path of the car becomes straight here. Okay, then if car is here, if your car is here at this particular point, can you say that the car is still rotating about this center of rotation? Yes or no? देखो कर्व्ड पाथ तो इतना ही था उसका, जहाँ पे उसने टर्न लिया वो कर्व्ड पाथ इतना ही है. आफ्टर दैट द पाथ हैज बिकम स्ट्रेट. सो इफ इट इज मूविंग ऑन द स्ट्रेट पाथ, सो सेंटर ऑफ रोटेशन उसका ये हो सकता है, या यू विल से दैट नाउ इट इज नॉट रोटेटिंग नाउ and this is no longer the center of rotation. Yes or no? What is your opinion? जब तक कार ये पाथ पे है, on this path A is curved path, जब तक आप बोल सकते हो कि it is rotating about this center of rotation. But as soon as the car is on this straight path, या जो यहाँ से start होता है path B पे, so whether you will say that it is still rotating and its center of rotation is this which we marked here earlier. Can you say that?
No, sir.
No, definitely we can't say. अगर कार ये कर्व्ड पाथ पे नहीं है, ये जब तक वो कर्व्ड पाथ पे है उसका सेंटर ऑफ रोटेशन ये है, इट इज द सेंटर ऑफ रोटेशन. But as soon as it comes on the straight path, so this center will not apply to this straight path. Car is not rotating with respect to this center of rotation. So you can say that this point was the center of rotation at particular instant, at particular moment, and after that moment the center of rotation has changed. So that's why now we call it as instantaneous center of rotation. Instantaneous center of rotation, because when suppose the path of the car is like this, ऐसे ऐसे उसका path है, so this portion of the curve यहाँ से यहाँ तक इसका center यहाँ पे होगा, then the portion of the path which is from here to here उसका center यहाँ पे है, then this particular curve has center here. this particular portion is having center here. So center of rotation is changing, keeps changing like this. So that's why you are calling it that this particular point is the ICR, instantaneous center of rotation, at that particular moment only. Yes. Are you getting the concept ICR? But in case of disk, in case of disk, if suppose the disk keeps rotating about this point only, then I will call it as center of rotation. I will not add ICR, instantaneous center of rotation, or I will call it as instantaneous center of rotation for all the time. No problem. You got it? Yes or no?
Yes, sir.
Okay.
Sir,
So, yes.
do we have to learn some formulas regarding differential?
Formula regarding?
Sir, it is written different for geometrical center. So there is some formulas for different figures.
Yeah. I will explain these points. Okay. So, first point is that it changes. ICR changes instant to instant. That's why this is called as instantaneous center of rotation. It is your first point. Okay. Next, when we study the motion using this concept ICR, okay, you remember all the concepts of the circular motion. Okay, so you know the concept of circular motion, that suppose there is the circular path. Yes, a circular path hai. Okay, and on that circular path there is some object which is moving. So you say that this object, say object A, is having circular motion, Okay, if the path is circular, then it must have the some center of rotation. Say that point is point O. Okay, and you remember that the distance between this particular point A, which is moving in this circular path, and point O, center of rotation, is called as the radius. ये concept आपको पता होना चाहिए. What is radius? Radius is the distance between the concerned point which is moving in circular path and center of rotation is called as radius. Okay, you remember it, you know it? आपको पता है ये radius? Yes or no? Yes or no? Radius पता है नहीं? आप बताओ.
Yes, sir.
Okay, keep talking. Radius. अभी नेक्स्ट, अब आप देखो कि ये आपको पता है कि नहीं सर्कुलर मोशन के बारे में. What we are interested in circular motion, and I assume that you know the circular motion. Okay, so let us see how much you know the circular motion. Okay, then you tell me, you know it already, that the velocity is a vector. उसमें क्या क्या होता है? मैग्नीट्यूड होता है और डायरेक्शन होता है. So if point A is moving, okay, how will you decide the direction of its velocity? Direction of velocity.
Tangent.
Yes, it is tangent to बोलो tangent to
Point A.
tangent to the circular path. Yes. Is it? Or tangent to radius? Tell me. Tangent to radius या tangent to circular path?
Radius.
It is not tangent to the radius. It is
Point A, right?
हाँ, point A का velocity का क्या डायरेक्शन होगा? Point A किस डायरेक्शन में मूव हो रहा है? ओके,
Sir, towards the center.
इधर हो रहा है मूव. पार्टिकल ए यहाँ मूव हो रहा है टुवर्ड्स द सेंटर, ऐसे मूव हो रहा है वो.
No, sir.
इट इज मूविंग ऑन सर्कुलर पाथ. तो उसका डायरेक्शन कैसे फाइंड आउट करेंगे? व्हेन समथिंग मूव्स ऑन सर्कुलर पाथ, its direction is perpendicular to radius. Perpendicular to radius. So what I will do, I will draw a perpendicular to radius. Okay, it is the direction I am showing. It is the direction of velocity of point A. And you remember that this velocity is perpendicular to radius. Always remember. Okay, so you make a mark. You make a mark that velocity of any point which is moving on circular path is perpendicular to the radius of the path. It is first point. Next point, it is about the direction. Okay, let us see the magnitude. What is the magnitude of velocity of point A? Suppose that the angular velocity is omega. Angular velocity, that is the velocity with which this radius is turning. This radius is turning like this, is omega. So if omega is given to you and you have been asked what is the velocity of point A, how you will calculate? Velocity of point A is
R omega square.
R into omega. Got it? R omega square is your acceleration. Okay, velocity of point A is R into omega. So any point, if you want to find out the velocity of point A, आप पहले point का radius find out कर लो. Radius means distance between point and the center of rotation, that is called as radius, multiplied by angular velocity. You understand this about circular motion? Yes or no? These 2 points आपको समझ में आया? Did you understand that velocity of point is perpendicular to radius and its magnitude is equal to R into omega? Okay, should I proceed?
Yes, sir.
Okay, so let us now take another case. For example, this is one rod, एक straight rod है और straight rod को ऐसे कनेक्ट कर दिया यहाँ पे पिन से. पिन का कनेक्शन है, से pin connection is like that. This rod can turn about point O. Okay, so suppose here is the point A. As this rod is turning about point O, okay, the next position may be like this. Okay, So how much time it will take? It will depend on the omega. What is the angular velocity of this rod OA? So it is the next position of point A, say A1. Okay. So suppose I obviously you see that rod OA is turning, means it is rotating about point O. You will say that point O is the center of rotation. What you will say? Point O is the center of rotation. Or I can also call the point O as the instantaneous center of rotation for all time, for all times, because ये center तो change होगा ही नहीं, क्योंकि आपने उसको यहाँ पे पिन से कनेक्ट कर दिया. ये लिंक ऐसे रोटेट होता रहेगा 360 डिग्री से this way. So point O is your ICR. Okay, if I say that find out the velocity of point A, velocity of point A on this link, so you will see I have to find out velocity of point A. So point A is what point A is doing? It is moving along the circular path. It is moving along the circular path. So I will apply the formula of circular path. Okay. So velocity of point A can be found using this formula. I know it, radius multiplied by angular velocity of the link. So radius of point A here, यहाँ पे क्या होगा radius of point A is the distance between point A and the center of rotation. So point A और center of rotation में कितना distance है? That is OA. So I will write down velocity of point A is equal to radius. Radius is equal to OA multiplied by angular velocity. तो ये लिंक लिंक का जो एंगुलर वेलोसिटी है उसको मल्टीप्लाई कर दो ओमेगा. This way you can find out the velocity of point A. Okay, if I say tell me the direction of velocity of point A, so क्या होगा velocity of point A का direction? Velocity of point A का direction is perpendicular to radius. Radius को perpendicular. Radius क्या है point A का? Point A का radius है OA. OA is the radius of point A. So इसको perpendicular. I will draw perpendicular to that like this. This is perpendicular to radius, and I will show that point A is moving in this direction. It is the direction of moving of point A at this particular instant. Understood? Yes or no?
Yes, sir.
Okay. Let us now consider another point. Suppose it is another point on link OA. Say this is the point B. Okay. You know that point B is also rotating. Point B is also rotating on this link. Link के साथ ही वो भी rotate हो रहा है. Point B भी rotate होगा. If I tell you what is the velocity of point B? What is the velocity of point B? You will say that point B is moving along the circular path. So this formula will be applicable, R into omega, radius into omega. What is the radius of point B? Point B का radius क्या है?
OB.
OB is its radius, the distance of point from center of rotation. So I will write here OB is its radius. Okay, and angular velocity of the link itself, क्योंकि लिंक अगर एक चक्कर लगाएगा ऐसा तो पॉइंट बी भी एक चक्कर लगा लेगा. बी विल आल्सो कंप्लीट वन रिवॉल्यूशन विथ लिंक. सो B will have the same angular velocity as of the link. Okay, so OB into omega is my answer. This way I will calculate velocity of any point B here. Okay, and if I have to show the direction of velocity of point B, so I know that velocity का direction radius को perpendicular होता है. So what is the radius of point B? Is OB. Okay, so इसके perpendicular. This is perpendicular. I will show it like this. Getting this? Yes.
Yes.
Okay. Now, interestingly, now we will calculate the velocity of ICR itself. Okay. So our ICR is 0.0. So let us say I want to find out velocity of 0.0, which is the ICR, instantaneous center of rotation. So formula for it is radius multiplied by angular velocity. So what is the radius of ICR? 0.0 का radius बोलो कितना है? I want to know the radius of 0.0.
0.
It is 0. रेडियस क्या होता है? जो पॉइंट का वेलोसिटी फाइंड आउट करना है वो पॉइंट से सेंटर का कितना डिस्टेंस है, दैट इज रेडियस. सो हमको सेंटर का ही वेलोसिटी फाइंड आउट करना है. सो द डिस्टेंस रेडियस विल बी 0 multiplied by omega. The answer will come as 0. So you can say that the ICR, instantaneous center of zero velocity, जो ICR का वेलोसिटी होता है वो कितना होता है? 0 होता है, क्योंकि वहां पे रेडियस 0 हो जाता है. Okay, it is your first point. Understood?
Yes, sir.
Yes, sir.
Correct. Now let us see the next point, that ICR is different. It is not for, it is different from, ICR is different from geometrical center. So see, if we consider this disk, say disk is uniform, symmetrical. Okay, so in this case इसका जो center of gravity है, G point, center of gravity and ICR both will be same at same location in this particular case of the disk. But when you consider the rod, then इसका जो CG point है, center of gravity, that will be here, somewhere here. अगर आप symmetry के से चलोगे, so it will be somewhere here in the middle of the length. So you note it down that instantaneous of center of rotation is different from the geometrical center of the body. So you do not confuse between a geometrical center and an ICR. That's the only thing over there, nothing much. Understood this? Yes or no?
Yes, sir.
Okay. So it's about the ICR. You note it down in 3 minutes. Then we will continue our discussion. How to find out the velocity, magnitude कैसे find out करना है, direction कैसे find out करना है. You note down in 3 minutes or 4 minutes, then we'll begin to continue. Did you note? Is it over?
Yes, sir.
Okay. So let's continue the discussion. You remember these 2 points very well. Direction, relation between direction of velocity and radius, and magnitude, how to calculate the magnitude. Okay. Yes, velocity analysis of a rigid body. Okay. So first of all, what is ICR then? Okay. So you remember that it is the point about which the whole body, complete body, is considered to be rotating around that point. That is called as ICR. Okay. So here you consider this a cylinder. Okay, this is a cylinder or a disc, you can say, and this disc is rolling like this. This disc is rolling like this. Now, can anyone tell me where is the ICR of this cylinder? One can easily see one can easily see that cylinder is turning, means it is having circular motion. So where is the center of rotation about which this whole thing can be considered to be rotating?
Point I.
Yes, correct. It is not the center point. It is not this point. It is the point of contact where this cylinder touches the ground. Okay. And about this point, you can consider that at this particular moment, at this particular instant, the whole cylinder is turning about this point. So this is your center of rotation I, and not the center of cylinder. Once you know the center of rotation ICR, you can easily do the analysis, velocity analysis. You know it. So for example, say I want to find out the velocity of point P. Point P is on the cylinder. Okay. So if cylinder is turning, point P is also turning. Okay. If I want to find out velocity of P, I know the formula R into omega. Velocity is equal to R into omega. So what is the radius of point P? Point P का radius क्या है? It is the distance which connects the point with the center of rotation. Okay, so you connect this line P with I. So it is your radius. So your radius is equal to IP multiplied by the angular velocity of the cylinder, omega. Okay. Similarly, you can calculate the velocity of any other point which is on the cylinder. So for example, you consider the point B. So how to calculate the velocity of point B? So first you know that what is the radius of for point B?
IB.
It is equal to IB. And as point B is also on the same cylinder. Okay. So whatever is the angular velocity of cylinder, same will be the angular velocity of point B. Okay. So that is omega. Okay. And further you can say that suppose if I have to calculate the angular velocity omega, okay, then in order to know the angular velocity, I must know the velocity of any one point. Okay. So suppose if I know the velocity of point
Sir?
P,
Sir, that should be IB, right?
IB, yes, correct. IB into omega, right? Okay. Please make correction. Now, if somebody wants to find out angular velocity, so in order to find out angular velocity, first we will write down the formula. It will be equal to Vp upon Ip. Or I can also write it like this, Vb upon Ib, like this. So what I need to know, that velocity of any point, I need to know that what is the velocity of any point on this particular cylinder. And after that, finding the radius. Okay, you have located that here is the ICR. You can just connect this point with point P, so it will be your radius. You just measure it by any means. Okay, and you write it down here upon IP. Suppose if you know the velocity of point B and not the velocity of point P, then I will be using omega equal to velocity of B upon IB, this distance. Understood this? Yes or no?
Yes, sir.
Yes, it is similar to the earlier discussion. Okay, but it is heading is different. So you also note it down in 2 minutes. Note down it. Take 2 minutes.
So, sir, can we say that ICR can never lie on the center?
No, it's not like that. Suppose if this cylinder is like this, suppose इसको support निकाल दिया, यहाँ पे ground नहीं है, cylinder is like this. Okay, it is in the air, you can say. And if this cylinder is rotating, देखो, if cylinder is rotating like this, ऐसे वहीं पे उसकी जगह पे ही वो rotate हो रहा है ऐसे. So the center of rotation is on the cylinder itself, right? Correct or not?
Yes, sir. Yes.
Yes. So in that case, you can say that here is the ICR, instantaneous center of rotation. अगर cylinder सिर्फ यही point के about में rotate हो रहा है continuously, so instantaneous भी use करने का जरूरत नहीं है. You call it as center of rotation. Okay. In case of ladder और rolling, जब ये सिलेंडर रोल हो रहा है तो क्या होगा, अभी आफ्टर सर्टेन टाइम क्या होगा, ये पॉइंट सी ग्राउंड पे आ जाएगा. देखो यहाँ पे जब ये रोटेट हो जाएगा ना, सो पॉइंट सी विल कम हियर ऑन ग्राउंड. ये उसका नेक्स्ट पोजीशन होगा ऐसे. सॉरी फॉर इट. सो व्हेन पॉइंट सी विल बी टचिंग ऑन द ग्राउंड, the moment is different. Now at this particular moment, point C has become ICR. Point C has become ICR. That's why the ICR is changing the position. It is called as instantaneous center of rotation. So ये जो point है यहाँ पे, ये जो ground का, ये it is the ICR for that particular moment. और moment change हुआ, इसका सिलेंडर भी पोजीशन भी चेंज होगा, दूसरा पॉइंट ICR बन जाएगा. Got it?
Yes, sir. Yes.
Okay. So should we move forward? Anybody wants me to wait? Okay, so let's proceed. Yes, it is very, very important. Location of ICR. Okay. Looking at the object, you should be able to say that where is the ICR. Okay. For example, we have considered this cylinder. ये cylinder हमने consider किया. ये ground है. And this cylinder is rolling. This cylinder is rolling like this. Okay. So here is its center और यहाँ पे एक point है. So say this point is point A and it is point P. So can you locate the ICR for this case? कौन से
Point B.
Yes, about which
B.
point the whole cylinder is turning? Whole cylinder is turning is point B, not point A. So I will say that in this particular point, point B is the ICR. I should be able to locate the ICR very easily. That is required. Okay. Now another case. Suppose there is this rod. Okay. और एनी शेप आई कैन टेक ऑफ द रॉड. ये एक शेप है, ये सॉलिड है, ठीक है. एंड आई विल पिन इट. उसको मैंने यहाँ पे पिन कर दिया ऐसे. So what is happening? That this rod is rotating about this pin connection, pin joint. Okay. So now can you tell me where is the ICR for this particular body? Suppose ये body A है, not particle. I am not telling it particle. This is the body A. Okay, this is point O. So which is the ICR for body A?
Point O.
Point O, right? So in this case, point O is my ICR because what is happening? This whole body is turning about this point. Okay. Next, consider this case. Okay, it is a curved path like this. Okay, it is a curved path, and on that path there is certain point, or you can consider it as car or a bus which is moving on this path. So can you tell me where is the ICR? ICR for this bus B. ये कर्व्ड पाथ है, उस पाथ पे बस जा रहा है वैसे. So where is the ICR for bus?
Where is it like maybe along the wheels?
Okay, any
Curve
other?
to curve.
Yes, correct. What you said?
Center of that curve.
Yes, whatever is the center of this curve. ये जो curve बन रहा है, whatever is the center of that curve says this. So this is your ICR. ये जो center curve का जो center है, That point is your ICR. Okay, then we consider another example. Say a circle is there, sphere is there. Okay, and on that sphere a particle is moving on that sphere. ये sphere पे एक particle move हो रहा है. So where is the center of rotation of this particle?
Center of circle.
Correct, center of circle. Whatever is the center of circle, that will be its ICR. Okay, and the beauty of ICR method is that it says you that at any particular moment t, okay, any motion can be considered as circular motion or rotation motion. Okay, according to this, even if a particular object body is moving in a straight line, even then you can call it as that this particle is moving in a circular path. Okay, are you understanding this concept? That even if the particle is moving along a straight line, it can be assumed that it is rotating about some center of rotation, which we call as ICR. We can assume that this particular body is rotating about this point. Okay, to prove it, okay, or just to have an idea of it, okay, I will give you the example of a bus, okay, which is going along a straight road. On a straight road surface it is moving. Okay, so can you assume that it is moving along the curved path? Can you assume? Suppose आप यहाँ से, for example, you go from Kurla to CST on a bus. So, and road is straight. Can you assume that actually you are moving in a curved path, not in the straight path? Can you assume that?
Yes, sir, by considering the center of our whole earth.
Correct, very good. See, what is happening, you are on the road which is present on the earth's surface, your bus is moving on the earth's surface. Okay, so even if you are moving in a straight path, actually you are moving in the curved path. ऐसे curved path है वो. Okay, only thing is that you are not realizing it, and that realization is because the radius of the curve is very large. That's why you are not able to realize that your motion is actually the motion on the curved surface, not the straight surface. Are you getting it?
Yes, sir.
Okay, so when you can say that when radius is very large, we consider the surface to be flat. जैसे जैसे रेडियस बढ़ेगा, देखो रेडियस अगर छोटा है तो कर्व ऐसे बनेगा, अगर और मैं रेडियस बढ़ाता हूँ तो कर्व ऐसे होगा, और रेडियस उसका बढ़ेगा तो वो फ्लैट होता जाएगा अगर आप उतना पोर्शन लोगे तो. If radius is very large, say if radius is infinity, even the straight path will appear as a part of the curve. So it is very important concept. Okay, so this particular case, when bus is moving along a straight line, at that time, you can say, what is the direction of bus? It is the direction of bus. And you know that center of rotation is, or radius is perpendicular to the velocity direction. Radius is perpendicular to the velocity direction. So इसका radius किधर होगा बस का? Either it may be upward or it may be downward. Okay, and this radius you can say that it is at infinity, or I at infinity. You can write that ICR of the bus which is moving along the straight line is at infinity. Okay, if you say that bus is moving on the earth's surface, then it is at radius which is equal to this 6400 kilometers something. If you say it is a straight line, no, it is not the earth's surface, it is totally straight, then I will say that ICR is at infinity. Its radius is very, very, very large. Got it? Yes or no?
Yes,
sir.
sir.
Okay. So you please note down these diagrams. 3 minutes I give you, then we will continue further. Is it done?
Sir,
Yes.
could you explain this concept again, the earth one?
Earth one, yes. So suppose you are in a bus and you are traveling on road surface. So road कैसा straight है, okay, no turn etc. So that time you will feel that you are moving on a flat surface, but actually you know it very well that road is made on the earth surface, and earth is spherical, earth is round, earth is spherical. Okay, so actually you are not moving in a straight path, actually you are moving along the curved path, and you are not realizing it because of the very large radius of the earth here. Okay, so point is that even a point, when a point is moving in a straight line, even then you can prove that the path is not straight, it is a curve, and it is having some center of rotation, and you can also locate the ICR. Where is the ICR? If you are telling that the path is curved, then tell me where is its center, because the curve has a center. So you will say that the center of a straight line is at infinity, got it? And because of this very large radius, infinite radius, you are unable to feel the curvedness of the flat surface. That's it. Is it understood?
Yes, sir, understood. But sir, you said that if it is 6,378 kilometers, then
Correct.
it will be.
Yes, 6,000 something, yes, kilometer. Then
So that's what. Then what happens? Then also uh, the I will remain the same, or it will change.
I will remain same. अर्थ के लिए तो same है. Okay. And if you are considering your horizontal motion, like turning of road, देखो ऐसे road तो straight जा रहा था. Okay. When it takes a turn like this, at that time your car is also turning at this point. ICR यहाँ पे होगा, and it is at the same time it is on the earth surface. So when I will be doing the velocity analysis, based on this center of rotation ICR, जो कि रोड सरफेस पर ही है और अर्थ सरफेस पर है, नॉट द सेंटर ऑफ अर्थ. इफ आई हैव टू टेक, सी, अगर ये वेलोसिटी है, इसका वेलोसिटी ऑफ बस, so velocity of bus I can write it like this: what is the radius of earth and what is its angular velocity of rotating about the earth surface. If I have to write the bus का formula here, ये small r पे, turning पे, so how I will write? Velocity of b is equal to r into omega. This omega will be its turning velocity around this center. This omega and this omega will not be same. Say omega 1 and this omega 2 will be different. Are you getting it?
Yes, sir, understood. Yes.
Okay. So let us move to the next point then.
Sir,
Yes.
sir, I had a doubt, sir. In this, that means we are considering the tangential velocity to be absent, right?
Tangential velocity to be
Absent.
why?
Because then if it is greater than the radial velocity,
See, if
then it will.
there is some velocity ka value, and if your radius is very large, so obviously omega 2 का जो value मिलेगा, it will be very less. means the turning velocity of the bus is so less that you cannot see that you are turning. आप ऐसे टर्न ले रहे हो, उसको आपको मालूम भी नहीं पड़ेगा यहाँ पे अर्थ विथ रिस्पेक्ट टू अर्थ सेंटर. लेकिन यहाँ पे क्या होगा, रेडियस का वैल्यू इज लेस और सेम वेलोसिटी है. ये वेलोसिटी और ये वेलोसिटी सेम है, रेडियस का वैल्यू बहुत कम है. तो टर्निंग का जो वेलोसिटी है रेडियन पर सेकेंड ओमेगा, इट विल बी वेरी हाई. Okay, and you will realize that your car is taking a turn. You will realize that. Are you getting? Tangential velocity will not be absent.
Sir, then this is non-initial frame, right? We are considering, क्योंकि फिर वो नॉर्मल भी 0 हो जाएगा.
कौन सा, ये वाला R?
नहीं सर, ये केस में, फर्स्ट केस में टर्न करते समय.
तो with respect to which ICR you are analyzing it, that is important ना. It is just for example. ये अर्थ का जो मैंने एग्जाम्पल जो दिया है, ये आपको समझाने के लिए दिया है. क्या, what was the my point? That even a motion which is totally straight line, we can assume to be the circular type. We can assume it to be the circular type. If you consider the circular motion, one will definitely ask, where is then center of rotation? If you are considering it to be a circular motion, where is the center of rotation? I will say that center of rotation is at infinity. Got it?
Yes sir.
Okay. So now let us see that how much you got acquainted with the concept of ICR. Okay. So let us see now whether you can answer it or not. It is a one certain body, certain object. Vinay. Okay. So it is a certain body and okay, of some geometrical shape. I am given that it has a point, point B. Okay, and I am given that this particular point B is moving in this direction. It is given to me that point B is at this particular moment, the point B is moving in this direction. Okay, and I am told that you find out the ICR for this body. See, the body is in motion. It may be in linear motion, translation, or it may be rotational motion. We have proved that even the translational motion can be considered as the circular motion. Okay, so if it is in motion, then find out the ICR of this body. If I have given the direction of velocity, कैसे find out करोगे आप? एक point है, point B इस body पे, उसका direction हमको पता है velocity का. तो अब इसका हमको क्या फाइंड आउट करना है? ICR फाइंड आउट करना है. कैसे फाइंड आउट करोगे?
सर परपेंडिकुलर.
Yes, correct. So we know one concept. That velocity direction is perpendicular to the radius. और radius का direction में ही हमको ICR मिलता है. So what we will do? We will draw perpendicular to the velocity. Velocity को perpendicular. And we say that the ICR should be on this line. अभी exactly कहाँ पे है वो तो हमें पता नहीं, और ये भी पता नहीं है आपको कि वो upward आएगा ICR. Okay, whether it will come upward or it will come downward. ऐसे भी हो सकता है ना, वो इधर भी आ सकता है ICR, क्योंकि it is also the 90-degree line. So ICR may be here or it may be on this side. Okay, so you will say that the information given is insufficient. With this much information, we cannot exactly locate the ICR. Okay, though we are knowing that it will be on this line, okay, but still information is incomplete. So I say to you that, okay, then I give you another point C. Okay, and I also give you the direction of that point, that the point C is moving in this direction. Okay, so now can you locate the ICR? Okay, point C and point
Sir,
B.
above B.
Yes, point C and point B both are on the same object. Okay. Yes, what you said?
Sir, it
How
will be above B.
it will be above B, but where it will be?
The intersection of both the eyes.
Correct, correct. So you know that the point C ka ICR will be same as the point B ka ICR, because point B and point C are on the same object पर है. So what I will do, I will again draw a perpendicular from point C in a direction perpendicular to its velocity. So I can draw perpendicular even downward also, but by intuition, by common sense, I am understanding that if I draw perpendicular upward, I can intersect this line. Okay, so this is my ICR. इस लाइन पे ICR आना था, तो ये लाइन तो वो छोड़ेगा नहीं ICR. And this ICR of point C will be perpendicular to this velocity, so it will be somewhere here. Everyone got the concept?
Yes, sir.
Okay, so you also note down this, like ICR, location of ICR from directions of velocity, from directions of velocities. You also note it down in 2 minutes. Then we will proceed further.
Sir, can you please explain again? Till then we are noting. Sir? Hello, sir.
Yes. So what I was explaining you, that if to know the ICR of any body, okay, I must know the directions of velocities of any 2 points on it. Okay, so suppose if I take point C and point D, if I know their directions, that point D is moving in this direction, okay, and you know point C is moving in this direction, it is given to you. What I know from the concept that velocity direction is perpendicular to radius, okay, and you know that on radius, at the end of the radius you find the center. So what I will do, I will draw the radius perpendicular to velocity, so see, this is the velocity direction, draw perpendicular to it. You can draw this perpendicular upward or downward, because you don't know actually where is your ICR. तो ये upward भी जा सकता है और downward भी जा सकता है initially. Okay, similarly the velocity point C and point D दोनों का center same है. Okay, So what is the direction of velocity of point C? It is moving in this direction. So radius of the point C will be perpendicular to this direction, perpendicular to this direction, like this. So I will draw, and you know that at the end of the radius you will get the ICR. So here somewhere you will get the ICR. Understanding this?
Sir, so whenever to find ICR, we should have two velocities, a direction, and we have to draw the perpendicular, right?
Yes. Means
The,
though
on both the direction perpendicular, and then the intersection will give the point of ICR.
Yes. So if velocity's direction is given to you, you can find ICR in this manner. और अगर आपको यहाँ पे तो ऑब्वियसली दिखता है, ये रोलिंग सिलेंडर का तो समझ में आ जाता है कि जहाँ पे वो टच कर रहा है ग्राउंड को, वो वहीं पे होगा ICR. ये it was also simple that this is turning about this point. Okay, so it was also simple.
सर वो फर्स्ट एग्जांपल में वो पॉइंट टचिंग भी कैसे आया वो नहीं समझा, मैंने आपको चैट बॉक्स में डाला था.
Okay, no, so you can ask now why to put in chat box. See,
Okay sir.
ICR is what? It is the center of rotation about which whole object is turning. Okay, so what is happening in case of cylinder rolling on the ground? When it is rolling like this, so it is turning about this point, not about the center point. आप कुछ उस पे आप कॉइन रखो ग्राउंड पे, कॉइन, place a coin on the ground and roll it. So when it will roll, the coin will roll, you note down that about which point the whole coin is turning. So you will find that it is the point of contact. Are you getting?
Yes sir, understood.
Okay. So I hope that you have noted it down. Okay. Then we will see another concept. Okay, and then we'll start the numerical in next lecture. So next topic is your tool link mechanism. Okay, so this particular mechanism which you are seeing here, you will find this in your IC engines, in the internal combustion engines which are used in bikes, okay, four-wheelers. Okay, so see how this mechanism is made. So here is it is this link, this rod is known as crank. Okay, and this crank is pinned here, यहाँ पे उसको pin करते हैं, pin joint, turning joint. So because of that, what happens, this crank can turn about point O. ये link ऐसे होता है. Then to this link, one more link is connected, one more rod is connected, which is known as connecting rod. And how is the connection between connecting rod and crank? That they are again pin joined here at point A. Okay, so what kind of motion will takes place about point A? It will be turning motion. So suppose it is my connecting rod and this is the crank. Okay, so what will happen after some time when crank will move? Okay, say crank will come here and this connecting rod will be like this at this particular point A. That is the angle between them. Angle between connecting rod and crank will change. The turning motion will take place between them. तो यहाँ पे भी pin connection दिया है दोनों के बीच में. Okay. After that, connecting rod to one end of the connecting rod, this piston is connected. Okay, this piston. Okay, and this piston is confined in the cylinder. इसको cylinder में confine किया है, so that piston will have only reciprocating motion. It will not turn inside the cylinder. Okay, see what happens when crank will rotate. When crank will rotate, then say point A will come here. After some angle, the point A will come at this position. So next position of the crank will be vertical. It is the next position. Okay, when this point A will move, okay, the connecting rod will also move with it. Okay, the connecting rod will move, but point A is common between connecting rod and crank. So it will be the next position of connecting rod. And you know that the end point of the connecting rod is connected to the piston. Piston cannot go out of the cylinder. It is the fixed. Okay, the piston cannot go out of the cylinder. You can say that point B, it will travel only on the straight line. Point B will travel only in the straight line because it cannot go out of the cylinder. So next position of the point B will be here, and piston will always remain in the cylinder. Okay, so how this how is this motion? This crank will continuously rotate 360 degree, and this piston B, it will reciprocate in the cylinder. ऐसे वो reciprocate होगा. Are you getting this mechanism? Yes or no?
Yes, sir.
Yes.
Okay. So see, yeah, I will draw it. What I did here, it is my line. I have to make in this mechanism, which is called as crank connecting rod piston mechanism. So what I did, I selected a piston. It is a piston. Okay, and I provided a path to it. So I confined it. I put this piston in the cylinder so that this piston should not go out of the cylinder. इसको fix कर दिया. So this piston will only reciprocate here. Okay. Now what I did, on some another point, I used a crank. It's a crank. This crank can turn. This crank can turn about this point. It is called as pin joint. Okay. So this is the crank which can turn around 360 degree. It is called as crank. Okay. Now I have to transfer this motion to the piston. So what I did, I used the connecting rod. I used the connecting rod to connect crank and piston. Crank and piston connect करने के लिए I used the connecting rod. So I used it like this. So the motion of crank is getting transferred to the piston through connecting rod. Are you getting this? समझ में आ रहा है?
Yes, sir.
Okay, so crank will rotate like this, and piston will reciprocate in a straight line. Okay, so if you observe the motion of all these three components, crank, connecting rod and piston motion is very simple. One can easily say that piston is having translatory motion. Piston का motion क्या होता है? Translatory motion. The motion of crank is rotational motion. And motion of connecting rod, you will find that connecting rod is translating as well as it is rotating, because the orientation alignment of different points will change on the connecting rod. Okay, so connecting rod ka motion is a general plane motion and piston ka motion is translatory motion. Crank motion is rotational motion. But we have seen the concept of ICR. Concept of ICR says that any motion, whether it is a piston motion or crank motion or translation or rotation or general plane motion, any motion can be considered as the rotational motion. Okay, and if rotational motion is there, you can find out the center of rotation also. So we will stop here. Okay, any doubt in this? In next lecture, we will be solving the numerical on this particular topic, ICR. You remember the geometry of the two-link mechanism? Okay. Then we will be solving this numerical, which is oftenly asked in the university. You can ask doubt, otherwise you can note down it. After 5 minutes, I will close the meeting. Please revise your concept of velocities, velocity ka direction, magnitude, radius. Okay, it will be very helpful while solving this numerical.
So